Alright, so the next problem asks us to prove that in an obtuse triangle, the side opposite to the obtuse angle is the largest side of that triangle. So let's draw our obtuse triangle, meaning that we have to have some really big angle in there, greater than 90 degrees. And let's label A, B, and C, where C is our obtuse angle. So how can we prove that the side opposite to the angle at C, AB, is the longest side? Well, in the previous problem, we had proven that the hypotenuse of a right triangle is the longest side of that triangle. So let's try to make a right triangle out of this problem. That's always a good thing to try out, and see if we can get anywhere. So I'm going to drop the altitude at A to BC. And then I'm going to extend BC. And we are going to get this intersection right there, making a 90-degree angle since we're dropping the altitude. And I'm going to, we're going to call that point and point D. Okay, now I can apply the Pythagorean Theorem, and we have that since AB is the hypotenuse, since it's opposite to the right angle, we have that AB squared is equal to AD squared plus DB squared. Wow. What can we do with this information? Well, DB is equal to DC plus CB. So this implies, since they're both positive values, since you can't have negative side lengths, that DB is strictly greater than CB. Again, because DB is the value of CB added with another positive value DC. However, this also is going to imply that DB squared is greater than CB squared by just squaring both sides of the inequality. Now, what can we figure out from that? Just trying to, whatever. DB squared. Alright, well, using our results from the Pythagorean Theorem, we also know that AB squared is greater than DB squared. I don't know why I keep drawing. It doesn't matter. BD squared. Whatever. Same thing. Because AB squared is equal to DB squared plus the positive value of AD squared, which implies that AB is greater than BD. Thus, we have that since DB is greater than CB and AB is greater than DB, we have that this is called the transitive property. AB is greater than CB. The transitive property says that, alright, so DB is greater than CB, AB is greater than DB, therefore we can conclude that AB is greater than CB. It's kind of like if person 1 is taller than person 2, and person 2 is taller than person 3, then person 1 must be taller than person 3 as well. That's the basic gist of what we call the transitive property. Okay, so that proves AB is longer than BC. Well, how do we know it's longer than AC? Well, looking again at our diagram, what can we use to show that AC must be smaller than AB as well? Well, we can just use this same logic, except now I would draw a my height like this. I would draw the perpendicular from A. Well, we could just do it like this. Hold on. Would that work? Not really. Whatever. Alright, well, what's some of the stuff that we can figure out? Well, applying the Pythagorean Theorem again, we can figure out that AC squared is equal to DC squared plus AD squared. Okay, we know that that's true. But combining with the first issue of the Pythagorean Theorem, we have that AB squared is equal to DB squared plus AD squared. That's from the first Pythagorean theorem we used in the beginning. Now let's compare these two. They both have the value of AD with each other. But which is greater, DC or DB? Well, obviously DB has to be greater because we have that AB squared. DB squared is the same thing as the length of DC plus BC squared. And then we have our plus AD squared. So this value here, DC plus BC, is obviously going to be greater than just DC alone. So we have that DC plus BC squared is greater than just DC squared. Because again, this side has DC plus another positive number, so it's a greater number than DC squared. Therefore, DB squared plus AD squared is greater than DC squared plus AD squared. So this formula here, or this side of the equation, is greater than this value, and this implies this is implying that AB squared is strictly greater than AC squared. And AB is greater than AC. And thus we have that AB is greater than AC and AB is greater than CB. So we have proven that the side opposite to our obtuse angle at C is the greatest side of the triangle by basically deducing all the facts from the Pythagorean theorems that we calculated.